I like the music. Yeah. What's up, noise? Shifter says easy. Get better? Oh, you guys gotta chill. Alright, I'm gonna stop the music. Actually, I do really like that. Where's this? All this. Cool. We got Sawyer up in here. Nice. Good to see Black. Yes. Oh, here, let me like Hypatia. Actually, let's I think there's like a cool spelling to it. Oh no. There was like an accent on the A. What's up, Sawyer? How's the AI bot stuff coming along? I was sending a funny picture. I feel like there's always a general progression in like what's like the next new thing. It was like NFT, and then it's the metaverse. Now it's AI. There's always something. It's cool. Because I think Noise was saying, what was it? WWDC was today. That's the big Apple conference. WWDC. Yes. Apple's releasing a VR headset. That's cool. A little late to the game, Apple, but you know that's how Apple works. They're late, and then they just come in with like, oh, and this is the de facto thing.
How's it going?
How's it going, Ramton? How's it going? Are you into VR at all, Ramton? Do you like VR?
I've tried the one game that I really like is like the boxing one.
Oh yeah.
It's like a workout, or like there's like also like an actual boxing one. That's the one I like the most. I know like a lot of people get
Super Hot.
busy.
They love Super Hot. Super Hot is good too. You've heard of that game?
No.
Here it's Super Hot. It's like you're fighting all these kind of like these ninjas, red.
Oh
things.
yeah, that would be.
Yeah,
I
this
want
one
to get a
got the
VR
guns and
headset,
stuff.
to be honest.
I gave one out last summer. I gave out a MetaQuest 2 as part of like one of the prizes of things. Yeah, this is a super fun game. People love playing this one.
Yeah, that seems good.
It's cool. I don't know. It's kind of like a novelty. Like I had one, or I still have one, and after playing it for like a week, I put it down. I was like, oh, I don't really care about this thing. So
yeah, there's like a shooting game as well. Like it's fun.
yeah, there's Population
one
One
of my
is.
friends has it, but yeah, I don't know if I wanna right now. I wanna drop any money on it. But
I know, because they raised the price on it. When they first released the MetaQuest 2, or it was called the Oculus Quest, is what it's called. Then they renamed it. But it used to be super cheap, and then because they were selling it at a loss, and then they realized like, oh shit, we can't keep selling it at a loss, so they had to raise the price. What's up, Shaq? Welcome back.
I'm on medicine.
You're on what? You're on the medicine, dude? What's up? Are you sick?
Yeah.
Damn.
No. It's like to numb my body type ish a little bit.
Why are you numbing your body, dog?
Because no, it's not funny. It's something serious.
Oh no, dude.
I feel so weird because I just recorded this video.
Yeah.
And I am so like out of it right now. I feel high, but I know I'm not high.
What
but
did
I
you
could
take?
be high.
What did they give you?
I don't know what it's called. It's literally like this doctor thing in the bottom. I can't read it. Some long ass shit. But
yeah, it sounds like you probably got given like muscle relaxers or something, dog.
Yeah, I think it's like a muscle relaxer because on the 25th of June I'm going to have surgery. So I have to like basically prepare myself physically and mentally.
Yeah, surgery is. I've only had surgery once, and yeah, it's not a light thing, dude. It's because they put you under, right? You're gonna go under.
Yeah. So
super weird.
So I think this is something to like ease it or something. I don't fucking know. Like,
it's to probably get accustomed to like just being knocked out, because honestly, it is kind of a scary thing to lose consciousness. I guess it's like screaming while you're awake and whatnot.
Yeah, I just hope I don't wake up, because if I do, I'm gonna feel a lot of shit hitting my spine. So
yeah. Usually, what happens? So my whole surgery experience, because I had to get I like screwed up my pec muscle snowboarding once, and like they had to go reattach it. And usually, what happens is they give you something like Valium or like a pill before, which will like chill you out and relax you, and then they bring you into the operating room. And they have you like count down from 10 or something, and then like it's like lights out. Then it's like you're waking up from a dream, and then you wake up and you're like, oh, what happened? And then they're like, oh, we like sewed you up.
Yeah, it's pretty scary. It's gonna be my first ever surgery.
Yeah, dude. Well,
Yeah, hopefully it'll go well. What's the surgery for? If you don't
what's it
mind
for? If you don't mind us asking.
It's like this thing I had when I was younger. It's kind of hard to explain, especially right now. If I remember, I'll probably just text you. It's
okay,
like,
yeah, just text it to me.
It's fuck.
Yeah, I know. Yeah, welcome to drugs.
It's okay. I'll tell you my experience with surgery also, so that it's
what did you have? What did you have, Rampton? What surgery did you have?
I've been put under, I think, twice.
Okay.
So one I was doing on my wisdom teeth, and one I was doing like one on my lower back. It was like a skin condition. They had to like remove something.
Oh man, okay.
And so the one on the wisdom teeth, like you know how everyone wakes up and
they're all silly and goofy.
Gibberish.
Yeah.
And I remember my ex-girlfriend was like, I was so excited for you to get up and start talking gibberish. All I remember is that I woke up from like almost like a dream.
Yeah.
And then I felt completely fine. I just started walking, and then the nurses was like, "What are you doing?" I was like, "I'm leaving." And they were like, "Go back to bed." Like,
I'm getting out of here. Peace.
And then they were like, "How are you walking so far?" I was like, "I don't know." And then they were like sitting me down. They were like, "This is gonna wear off." I was like, "I don't feel anything."
I don't feel shit. Y'all didn't do anything to me. I'm here.
So yeah, like I didn't feel anything except the pain started to come out.
Oh yeah. That's.
I was like, I feel like this is the worst type of anesthesia that like I didn't feel any high or happy or anything. It's just like the pain was gone, and now that it's wearing off, it's just the pain is coming out.
Dude, maybe you're like Deadpool. You can't feel pain or something, dude. Like,
yeah.
Like drugs just don't work on you.
True. Yeah. And then the second time, it's like, okay, so you know how it felt so weird. I felt like I was having like a dream the whole time.
Mm-hmm.
And you know how like there are, I don't know how to exactly explain this, but you know how like you have like one of these window tabs that you open up, and then there's like 1,000 of these like open up like on your screen sometimes.
Yeah.
So it felt like I was like seeing something like that, and then these windows started like closing slowly, and then I just like was looking at the door.
Oh wow.
Like somehow it was a transition between like a dream. Like I don't know whether I was awake and I couldn't figure out what's going on, but it felt like a bunch of like 3D like boxes that are like stacked on top of one another. Yeah. And they slowly started to merge into one shape that was like me looking right at the door.
So you like dissociated and then like reassociated reality or something kind of.
Yeah. And I was like, what's going on? And then I remember being high. But like I was fully conscious of what was going on, like what I was saying and everything. But like things were weird. Like I went to the doctor, and then I was like, "Yo, doctor, this was lit. What did you guys give me?"
What'd you guys give me?
And the doctor was like laughing, and he was like, "We gave you ketamine." I was like, "Yes,
yeah."
And then he was like, "Yeah," and then he was like, "But we don't give you like that much." And I was like, and people do this drug on their own, like for
recreationally. Yeah, for sure. Yeah.
And then he was like laughing. He was like, "Yeah, I mean, some people do it. I wouldn't advise it." I was like, "You're gonna die."
Sound like you almost went into a K-hole. It sounds like a K-hole almost.
Yeah, but
all the sensory stuff. That's crazy. Yeah, I have actually been noticing that they do this on my sister. She's a nurse, and she sends me all these TikTok videos and stuff. But yeah, apparently they do give like ketamine to patients, and they'll trip you the fuck out. It's now being used for like therapy, I think, for like PTSD and stuff. But
spinal decompression.
Spinal decompression. Okay, that's what's happening to you. Damn, you're young for having spinal problems.
Are they?
I don't know. I think it's like in my family or something. Like
Oh,
I don't fucking know.
All right, get some rest, Shaq.
Bro, I'm let you know. I was trying to record a video, like
Yes.
a little uh, fuck, bro.
You got it, dude. You got it. It's all right.
Life
Don't stress
life
yourself.
update, a life update
Life
on
updates are
my
good.
channel, right? And
Maybe don't do it
then
under the influence of anesthesia though.
halfway in the game, I just fucking lost track of what I was
Damn.
doing. I just redeemed something. I haven't been in this
Thank you,
chat
dude.
in
Thank you, bro.
forever.
Yeah, you're making me hydrate. I think you should hydrate too, honestly, bro.
I drink like a lot of water already.
Yeah, good. Hydrate and go to sleep. Like, sleep it off, dog.
Yeah, I just had to do something, and then you were on the stream, so I checked on you.
I appreciate it, dude. I was, I miss you. Always come by, say hi and stuff. But
Yeah, I miss us too. Pause.
cool. Pause. All right, get some rest and stuff. I gotta help some kids with some math questions. Cool.
Yep.
All right. Good to see you, Pat. Good to see you, Shaq.
Bye.
All right, let's kick
Bye,
off. Bye, Shaq. Let's kick off the stream. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold. Streamer will help you out with math homework, science homework, life problems. You know, we're here for it all. Anesthesia. Yeah, cool. A new one. Let me go through some of the chat real quick. All right. Nobody asked. There was also this one guy who put under but stayed awake and felt everything. He couldn't do everything. That's always like my worst fear, is that if they give me anesthesia that I'm actually awake, but you're still paralyzed and you can't do anything about it, so you're just feeling everything. You can't say anything. Yeah, that's a very rare thing. That doesn't happen very often to people. Noise says, new challenge. See how much alcohol Ramit can drink until he feels something. That one's good. Polish rectified spirits. Yeah, the Polish have some interesting drinks. They like they take like plums and stuff and they like ferment them. Interesting. Okay. And nobody else said they used to operate on babies without anesthesia because they thought they couldn't feel pain. Huh. That's an interesting one. Yeah, babies can definitely feel pain. Whether they can be vocal about it, I guess. Okay, cool. All right. Lots of stuff. Awesome. Great. Interesting. All right, let's see. Who's the first question today? First question. Oh, is Noise. Okay, Noise. Oh, this is cool. Oh, I love this. Velocity versus time graphs. Actually, I just released a TikTok video on this one. This is actually a pretty good one. Says motion of a particle is represented on the velocity graph shown below. The motion is given by the equations. Great. Wow, what? This velocity is third order in time? That's not good. What does that mean, Noise? If there's a t cubed in the velocity, what does it mean that there's a thing that is non-zero? Pretty cool. I was showing this earlier to people. Let me see. But yeah, okay. So what happens is, we have. Oh, where was this? I have this picture of it. Wikipedia. It was like jerk, snap, crackle, pop, stuff. Where is it? All the derivatives and stuff. Yeah, here we go. Love this picture.
I've heard of jerk, not anything.
Right? I haven't heard of the snap, crackle, pop, dude, but it's real, apparently.
I feel like this is like definitely physicists just making random words just so that
it's like the up down beauty and strange, you know, where all the subatomic particles and stuff that they came up with. Yeah.
I mean, I know, for example, there was some people that intentionally named their theorem in their last name in a certain order just so that it like spells out something vulgar.
Oh my god.
5 mathematicians, and I was like, "Do you know how smart you gotta be to be able to pull this off, and nobody can tell you anything?"
Yeah, I know. Yeah, to have the chutzpah for it, dude. And they also do this with scientific articles. There are bounties for people to put certain words within scientific articles, like certain like ridiculous phrases. And if you can get it published in a peer-reviewed journal, like you win a prize. I think I've seen this before. Or what they try and do is they have the first letter of every sentence right within like a column, like spell something out. There's a whole like funny thing. One second. There's like it's like bounty on ridiculous words in peer-reviewed journal. Yeah, I mean we have fun, dude. We have some obscure words. I'll find it. There was something I remember seeing. It was like a challenge or whatnot. But yes, what we're getting at here, Noise, is that if you keep taking derivatives of things, you get to what's called like the next moment or the next order of a quantity. In this case, position you derive, you get velocity. Velocity you derive, you get acceleration. And if my velocity is already of the order like t to the third, that means I can take at least 3 more derivatives before it's not non-zero or what. So you can probably get down to snap or crackle here. Anyways, the reason I say this is because most times when people are going to do physics questions with position versus time graphs, velocity versus time graphs, everything usually stops here. Like acceleration is usually constant and not dependent on time. And as a result, velocity graphs shouldn't really have curvature to them. If they do, I don't know what's happening. This is some weird particle. This is some weird movement. Okay. Says a particle returns to its starting position at time t. Find the velocity of the particle at time t. Oh, so they want to know this. Oh, that's cool. All right. How do you know how to do this one, Noise? You have an idea how to do this one? This is actually kind of a cool one. Yeah, it has to come down to, if you want to know what, let's say, like, so delta x, which is change in position, or I think this is technically displacement, what it is. That's always going to be equal to the integral from, we say, like, t equals t0 to t equals t final. Yeah, he says, I feel like I could work through it, I just couldn't be bothered. That's okay. That's okay. Because, someone else will get something out of this, and I always like a little practice on doing integrals again. So what's interesting here though is that this velocity is what we call a piecewise function. So for those of you that don't know, like piecewise means it gets broken up into pieces, and those pieces are defined by what the values of are. So in this case, we have velocity versus time, and I have that this velocity graph, like this curve right here, is equal to this equation for t is between 0 and 4. And then once we get to t equals 4, it turns into a different type of equation, which in this case is just a nice line. Cool thing about piecewise functions, in this case, this is also, you guys will see this word before. This is called, is it discontinuous? Or like the derivative is discontinuous?
Yeah, I guess they say non-differentiable.
Non-differentiable. That's the word I'm looking for, right? Yeah, good. This is non-differentiable. And so anytime you see any like really sharp points, which are usually come out of having a piecewise function, that's where you can say like it's not differentiable there, or the derivative is not continuous. I always got confused when I was younger, like what continuity was. But in general, it's can you draw something without lifting pen up? Okay. So
there's one actually once we get to this problem, there's like a cool graph I'll also
okay. Yeah, cool. So this is pretty decent. This is pretty straightforward. I'm just gonna integrate this function from 0 to 4, and then I'm gonna integrate this function from 4 to a time t. Okay. Oh, so they want it as a function of t. That's cool. Okay. So, and I know that the summation of that displacement has to eventually be 0. So since all this area is underneath the x-axis, this means that this is going to be negative displacement, and then here we're going to end up getting positive displacement. And so they're going to cancel each other out. Oh, okay, very cool. So eventually, I can say that just this is going to equal this. So I'm going to say, well, the negative of it, sorry. This, and what is this? This is 2t squared minus 3t minus 1/3 t cubed is going to have to equal this one, which is 4 to t of 1.5 lowercase t plus c. All right, cool. Integrals. I know you guys know how to integrate. If you don't, you can ask me. Okay, so this is going to be 2/3 t cubed minus 3/2 t squared minus 1/12 t to the 4th. Okay, then let's just distribute the minus. Sorry, that's a minus. That's a plus. That's a plus. Okay. That's from 0 to 4. And then this is equal to 1.5 t squared over 2. So what's that? That's 3/4. Interesting they put a decimal here, but they put a fraction over here. Yeah. 3/4 t squared plus ct. And this is also from 4 to t. Okay. Then I plug this in for everything, and I subtract it from plugging this in for everything. Oh, this is ugly. Okay. I can see why Noise was like, I just don't want to do this. I feel like when you get to a point where you get so smart that you know how to do things, this just looks tedious. It is. It is tedious. And then this is 3/4 big T squared plus C big T. Minus plugging that, so what? That's minus 12. 4 squared is 16. 16 over 4, yeah, 12. Minus 4C. Yes. Okay. And we want to find the velocity at t.
So, and here, I'm pretty sure you can find C as well.
Right?
Yeah, because you have continuity. So at t equals to 4, you should have the same velocity.
I like that. I like that. Yeah, because there are two things that are unknown here, right? I don't have t and I don't have c, but yeah, that's a very Rampton brings up a very good point here. Yeah. And this goes back to the continuous thing we were talking about. Because this function and this function, as we get close to t equals 4, equal the same velocity, right? Do you see how it doesn't jump or anything? They should be approaching the same value. Then at this boundary, when t equals 4, this function and this function should equal each other. So, yeah, very good. Yeah, I was wondering about that. I was like, wait, like two things. 4⁻³ is equal to 6 plus c. Okay, so that's 2 times 16. Oh, man. Oh, so much math. Does 64 even go? Does 3 even go into 64 in a nice way? My middle school brain, it doesn't, right? Yeah.
64 is just 2 to the 6, so.
Oh.
Just...
but we got this 1/3 here. It's just ugly. Oh man, dude, Noise. This is such an ugly question. Okay. C is equal to 32 minus 12, which is 20. 20 minus 6 is 14. So what's that? 14 minus 1/3 times 64. That's 52. 52 minus 64. Negative 12 over 3. Oh, okay. I think it's just negative 4. I think that's what that equals. Let me know if it's not. I'm pretty sure it is.
Well,
did I do that right? Let me think. Sorry. This is 32 minus 12, right? That's 20.
Yeah.
Then minus 6 is going to be 14, right?
Yeah.
So then I have 14, and then if I to the third. Oh, that's 42. Oh, sorry. That's 42 over 3 minus 64 over 3. Oh, that's not something nice. Okay. So it's negative 22 thirds. That's what it is. I was off by 10.
Yeah.
All right.
You can just plug it in for C, I guess, already there.
Yeah, right? Yeah, I can just plug this in. And then, but then I need to solve for T. Oh, man. Which is going to be quadratic. Quadratic and T. Okay, good. Noise. Yeah, noise got the same value for C. That's good. Okay. Negative 2/3 times 64 plus 48 over 2 plus 256 over 12 fourths squared plus minus 22/3 T minus 12 plus 88 over 3. Okay. Why? What? Where did this question come from? Like, why do they just give you this? This is torturous, dude. This is just like torturous algebra. Nobody asked, what the fuck is this? Okay, here. Let me explain real quick to nobody, because nobody's wondering. No, nobody. All we're doing here is we're trying to solve for a variable here, which is T, is what we're trying to do. I know there are a lot of numbers and it looks really scary. But actually, it's a good question. Nobody, like, what grade are you in? Like, maybe you haven't even done quadratic equations. Maybe that's why this just looks like there is a lot. Yeah, there's a little bit of math, but it's mainly just algebra. Is what it is. He's in 7th grade. Okay, I don't even think 7th graders have gone through the quadratic equation at this point. I don't think so, right? I mean, I was pretty advanced in 7th grade, and I just started going. Yeah, 7th grade. Okay, don't worry too much about this. Nobody. This is it's a little above what you'd be dealing with. You know what? I could solve this by hand. I'm not going to. So I'm going to show you how you can do it. I know how to do them, but we don't do them until 8th grade. Yeah, that's okay. Where's my calculator? Where'd you go, calculator? There you are. Oh, it's the wrong color. Okay, good. Awesome. All right. I'm just gonna see if these two things like solve to negative 2 times 64 plus 24 plus 256 over 12, and then let's add the 12 from the other side. Then let's minus the 88 divided by 3. Okay, cool. And then this was 0.75 T squared minus 22 over T. Cool. Trace them. If they come to be anything nice. Or you don't actually. Okay. There's that. Okay. So we gotta zoom out. Uh-huh. There we go. Line. Where'd she hit? Oh, it hits in 2 places. Okay. That makes sense. We could have 2 different T's for this. I don't like that. I don't like that they're both. If I do the intersect of what this one. The TI-84 sickens me, dude. No, it's the one calculator in the US that they allow you to use on all this like SATs and stuff. You kind of have to use it. Okay, I got T is equal to 2.8. Is that what you got, Noise? Did you get 2.8? There's technically another solution as well. But that doesn't make sense. I don't think there should be another. If I look at this, there should only really be one, right?
It
Graham?
probably is going to give like two solutions. One of them is going to be rejected. So like, how many solutions do you have?
I have
Which
2,
one?
but I should only have 1, right? Because there should be a set amount of negative area here, and then there's only so much positive that I.
Yeah, I mean, like, what are the two solutions? I guess
2.8. They're both positive. Is the problem? 2.8 and 2.8 doesn't make sense because
2.8 is because
it's
less
below.
than 4.
It's less than 4. Very good. Yeah, thanks, Ramsey. Yeah, you're right. Yeah, so this is not a good one. 2.8 is not a real solution, right? Okay. Yes, the other one is though. Yeah. Okay. That's what I was looking for. I was like, I need one of these to be nonsensical. Okay. There we go. Okay. That's 6.97. Okay. And then now if you want the velocity there, at this time, you just plug that in for here. So that's just 1.5 times the 6.7 plus the negative 22 over 3. That becomes, that's 1.5 times 6.7, good, minus 22 thirds, 2.72. Okay. I'm assuming it's meters per second. That's what it should be. Yeah, lots of stuff on that one. That's a and honestly, like, I could have spent another 20 minutes probably doing all this algebra by hand, but I didn't want to. At the end of the day, this is why it's very useful to be able to know how to use your calculator to solve things. This is why graphing calculators are so powerful, is that you can always set one side of an equation equal to, for instance, some function like y1. You can set the other side equal to y2, and then you just graph them and find out where they intersect. Integrals seem way too confusing. They're not too bad. Nobody. Don't worry. Integrals actually aren't that bad. There's some simple rules that I can go over later for doing integrals. They're not that bad. They're actually one of the easier things in calculus. Series and whatnot, those get difficult. Although it is, yes, it's basically how you just find the area under a curve. Okay, cool. All right, good job, Noise. Integrals aren't the worst. Famous lad word. Well, they can be the worst, especially if you have to start using those tables of integrals. I don't, yeah. Or if we start doing like hyperbolic stuff and whatnot, yeah, that stuff can be. Who am I giving this to? Nice. Okay, cool. All right, let's see. Next. Oh, you wanted to say something, Ramton, right? Like a graph or something? What was up?
Yeah. Oh, yeah. So, because you mentioned something about differentiability.
Yes.
And so, any I guess like zooming on this graph as well, just so that we have like a clear kind of example of what it is.
Here, let me put a new. There you go.
Yeah. So like, right there. Looking at this graph, at the point where we have like t equals to 4, we have like a jagged edge, right?
Yeah.
So idea of continuity for the people who are like trying who are what's it called, if they're any confused by the terminology,
like what does continuous mean?
So continuous or continuity means that it kind of like all is like a smooth graph. Like you can draw this graph without ever lifting your pen off the page. So you can see that this is a continuous graph. Now, however, if we look at the derivative at t equals to 4, the derivative is not going to be is not going to exist. The reason is because slightly to the left of 4, or like the limit as we reach 4 from the left side is negative, and then when we reach from the right side is positive, right? Exactly. So if you were to follow like a path, so this makes it so so that they're different. The derivative does not exist, since it is called non-differentiable. Now, there is a graph that makes it continuous but non-differentiable at every point. That means
interesting.
There's jagged edges at every little bits of it, and but there, it's continuous. Now, if you the reason
How
I
would you
know
do
this
that? How would you do that? How would you have jagged edges but it's still continuous?
so Google Weierstrass's function. I think.
Oh, is this? Oh, we were talking about this earlier. Weren't we? This was one of the questions.
Oh, was it? Oh, okay.
Wasn't it the Weiss? Was it? Wait, what's this one?
Weierstrass function.
Weiss.
Yeah. So he did the Strauss. It's just one word.
Oh, Weierstrass.
Weierstrass. Yeah.
Oh, wow. Cool.
So it's like this is a cool example of what we also call a fractal. So when you zoom in, you just keep getting more and more copies of this as well.
Oh, I see. Okay.
And so that makes it so that this graph is continuous, as you can see, but every time you zoom in,
yes,
you end up getting
something that's just even more just jagged.
Yeah.
Oh, I see. Exactly. So you can't take the derivative anywhere because as you try to zoom in, it just becomes more and more just like rapidly changing points. Wow.
Yeah.
Oh, that's I didn't know that.
We have someone in this or Twitch that is a algebraic geometer.
Yes. Yeah. So this is Hypatia. He showed up on Friday.
Okay.
Yeah. I think just found the Twitch and whatnot, but
okay.
I'll let them speak for themselves. But something I think they're a math professor.
Oh,
Hypatia,
okay.
you tell me, Hypatia. It was something. Actually, sorry. Very interesting story. I think they're a asylum seeker from China who came over to the U.S. and is now teaching math in New York. What it is.
Ooh, okay.
Yeah, there's a very interesting story to Hypatia. Earlier. Oh wow. Okay. This function is dope though, bro. What?
Yeah, it's a pretty cool. It's
Oh,
pretty cool function. Yeah.
See, this is the type of stuff that like again I was never even introduced to this when I was in math class because it was kind of just here learn integrals, learn derivatives. But I feel like if we showed students like hey, there's actually some cooler stuff related to math, I would have been less scared of it. I would have been like, oh, okay, there's a point to this. Like, how did they come up with this stuff? What topological space? What? Oh, it's a Riemann function. Ah, okay. See, and then we learn Riemann sums and everything for integrals, but oh, I see. This is the cosine thing. Okay.
Yeah, so it's defined by the by like a Fourier function.
Sure. Yeah, this looks like a Fourier decomposition.
Yeah.
Ah. Okay, very cool.
Hypatia. Well, nice to meet you, Hypatia.
Yeah, nice to meet you. Oh, yeah, one sec. Hypatia, come up to speak. Yeah, come up to the stage.
I would like to learn some.
Say hi. Yeah, say hi.
Algebraic topology.
Yeah.
Hello, can you hear me?
Yeah, I can hear you, Hypatia. What's up? What's going on?
Yeah. I just want to tell you, like, usually when I encounter this kind of integral, I will teach people about the Liouville's theorem and also the closed form Liouville theorem. So
Louisville
that's an
theorem?
interesting one.
Oh, the Louisville.
Yeah, it's telling you, for example, so basically it's saying what kind of antiderivative can be expressed by elementary functions.
Mm-hmm.
Yeah, well, that's the thing. Like for example, antiderivative is supposed to be thought abstractly as an operation. Like it has properties.
Sure.
Some of the like polynomials you can have elementary antiderivative, but
sure.
There are also other like special functions solution or things can be expressed in terms of special functions by using the differential field extension.
These are all words where I'm just like, what? Yeah, I get what you're talking about, like with integrals having nice, the integral of this is sine, or the integral of this is cosine, or this is e to the x. But
basically, this theorem tells you when can it be expressed in such a nice form.
I see. Can't everything be expressed as like? Yeah, go on.
Theorem.
What theorem was that again? Say it again. Sorry, Rampton.
What was the name of the theorem you said? Is it the Sturm-Liouville theorem?
No, it's not a Liouville number. That's a
Yes.
Liouville number is about the irrationality of
Okay.
not a number. The Liouville theorem is in differential algebra.
Differential algebra. Okay.
What's Liouville theorem?
Yeah, no, not like Liouville has a lot of results.
Yeah,
You need to
he did a lot of stuff.
specifically say Liouville's theorem differential algebra.
All right, let me do it. Let me find it. I'm gonna do it, dude.
I thought you were talking about the Sturm-Liouville theorem for like the differential equations.
That's all related. Differential algebra has immense application in determining or probing the properties of the solution of differential equations.
Oh, okay.
Yeah, this is the one. This is
Okay.
telling you, like,
What?
so elementary functions are like arithmetic operations and the composition of
Sure.
elementary functions, such as, oh, well, just the exponential, because other things you can express it with that, but well, yeah.
Oh, this is
And
cool. Yeah, because e to the minus x squared is like usually not something that's easy to take an antiderivative of, right?
That's called the Gaussian integral, I think.
Oh wow, this is super cool.
It has a very quite geometric proof that like how you evaluate it.
I see.
Yeah.
Oh,
There's
very
actually
cool.
like the proof for this is actually really cool because you can you pretty much extend this to like a polar field and then you're taking the like an integral in 3D almost.
Oh, I
when you're
see.
trying
I
to
think this is maybe
find
a
the proof from negative infinity to infinity to find that it's pi. It's like you're looking at it from like a 3D point of view, I guess.
oh wow.
Yeah, that's called the analytic continuation. One quite interesting property about that is that when you extend the extension is unique. There is no other way no other complex analytic function that you can extend it beside that one.
Oh, very cool.
Okay.
That's
Like
cool.
the e to the negative x squared?
I think so,
The-
because like the result basically says if you have an accumulation point in the domain, then the values the function takes there determines the entire analytic continuation.
Okay. The accumulation points for yeah, can you give a because I know they also call it fixed points sometimes. Accumulation point is like the more general term.
Limit point? Is that what it
Accumulation
is?
points is
point,
like
I
a
think.
set. Yeah, that limit point. That's why, like, basically, you have a point, say, on the real number line, you have, let's say, n, 1 over n. Like, you have a sequence of points for all positive integer n. Then
Yeah.
this is like the point 0 is an accumulation point because
Yeah, okay.
it
Where all
accumulates to there. You cannot, yeah, like there is a topological version for that, but yeah.
Mhm.
It says 0
I
is a
think that-
boundary point, but not a limit point. Okay.
Yeah.
Huh?
I think the question that what's it called? Teacup has posted.
Yeah.
I think that's that has something to do with limit points as well.
Yeah, here, let's pull it up. Let's pull up Teacup's question. I like that. Maybe you can help with this one too, Hypatia. This is the type of stuff that
Which question?
I'm gonna post it. 1 sec. It's gonna be coming up in here in just a second. Get it. This is where, so we have a couple students here, Hypatia, that are bored in their math and science classes because they already understand all the stuff that's happening, and
yeah, I know, and I'd like to teach them like everything they want to know.
Oh, perfect, exactly, yeah. And this is where I lean on people who have more math knowledge than I do, because okay, cool. So here we go. This is the question. It says, let G be an open and an R. For those who don't know this means it's a real number, what we say. And suppose that for every n contained in n, I don't know what this means. Hypatia, what does this mean? What is this big N?
In a natural number. That's
Oh, that's natural numbers. Okay.
0 or not, but yeah, like the interval 0 contains a point that does not belong to G.
Prove that 0 does not
is
belong to
not
G.
in G.
Yeah.
Okay.
Yeah. What is this?
That's exactly what I was talking about. So you can draw it, like draw a real line.
Draw a real line. Okay, let's do it. Let me draw a real line. I'm gonna do it. All right. Y'all guide me. All right.
Yeah, and so an open in R by definition it will be the arbitrary union of open intervals and then you can take a finitely many intersections.
Okay. All right. Let me decode that myself.
So,
That means.
yeah, so I'll write a few stuff also. So
Okay, cool. Y'all be my translators.
I think yeah. So I think Hypatia also, because this is the extent of what's it called? This is the extent of like real analysis or topology that like kind of goes over my head a little bit as well. But I'm gonna try my best to also explain the parts that I understand as much of it. Because he said a terminology that is not actually that trivial. He said finitely many, which is not the same thing as infinite.
Finitely many is the opposite infinite, no, right?
There is an arbitrary number.
Also very complicated. Like finitely many means that so infinite is very complicated. It means
infinity is like not even a real thing.
Finite.
You know, like yeah, right.
Like there can be multiple cardinalities. When I say infinite here, I mean countable. And then there can be uncountable ones, and there can be to determine what uncountable means in terms of cardinality is a very deep thing that was solved like 50 years ago.
Okay.
Like
what do we mean by what do we mean by like cardinality? Is that what we're saying? Cardinality?
Yeah. So cardinality, when you have a finite set, cardinality means just how many elements in that set.
Okay.
And so if you can like finite sets as in 1, 2, 3, that's a finite set of cardinality 3.
Okay.
But if you say all the natural numbers, that's an infinite set with cardinality LF0.
Okay. I see. Okay. Cardinality is size. Got it.
Of natural numbers, I forgot how they show it, but LF0 it looks like this. It's an Aramaic
alpha with like a dot like that.
Yeah, LF0. So it's like the first what's it called? Like the smallest cardinality for the infinite things.
Yeah, so back to what I was saying, open in a on the real number line are like they are built up from open intervals. There can be unions of them, so you can have like two disconnected pieces of open interval, or you can have two intersecting open intervals that merges into one open interval. But you can only have finitely many intersections, because if you have accountably many intersections, you can make it that like the intersection becomes a single point, which is not open anymore. It's closed. So closed means you have a like it's the complement of open.
I see. Okay. Open is kind of like infinite, and closed would be like finite.
Not quite. Like closed interval.
Close enough. Yeah.
Closed.
Close.
Closed means it contains all the limit points. One definition of that is like at least in the standard topology on R.
Okay. So related to this question, then, we're saying.
Yeah. So just draw an example of open set in R on that number line.
Open set in R would just be something like this, right? It's just it would be all the numbers. Exactly. Right. Cool. That's an open set. Okay.
Okay. So you can see here, this open set contains 0.
Right. Good. Okay. Yes.
So you should be able to see that the condition the problem gives is not satisfied by this open set.
Oh. Okay. Oh.
Right?
Okay.
So for every n
Yes.
for every natural number n, the interval contains a point that does not belong to G.
Yes.
So why this doesn't satisfy it is because there exists and such that the interval open interval from 0 to 1 over n does not contains a point that belongs to G. Contains
Got it.
this is a there exists and for all points that belongs to G. So the negation will be
Oh, I see. So the logic is like proving like the contrapositive of it, kind of. Is that what you're saying?
Yeah.
Gotcha.
Except when you do a negation, you change the quantifier too. So here it's telling you that this specific open interval contains does not contain a point that belongs to G.
Right.
Yeah.
I got you.
So one thing is also, is it okay if I delete this one?
Yes, go for it. Go for it.
Yeah, so the reason I wanted to delete this is because it would be easier to do this question. Because here's the thing, the intervals is from 0 to 1 over n, and n is an element of the natural numbers, which means that the biggest this can be is from 0 to 1.
Right. Okay.
So that's why I wanted to just draw this and do it like this.
Okay. Let's see this. Yeah.
1, this is 0.
And we have all the fractions in between because n can go to whatever.
Yes. So it would be like 1/2. This is like the second interval. There's like the 1/3, 1/4, and then all this stuff.
Sure.
And so, yeah, I think I don't know if you maybe Hypatia could also write on the board, but my thought was if you define a set such that A0 is an element of 0 to 1, and for every interval contains a point that does not. Yeah, A0 is an element of 0 to 1, and A0 does not belong to G. And then I'll define A1 to be an element of 0 to 1, 2, and then A1 does not belong to G. And then I can keep going. So AN would be an element of 0 to 1 over n,
which is still going to be slightly greater than 0, right?
Also, this is frowned upon, so I'm going to call it K.
Okay.
Because they can. And then this is 0 to 1 over K. So what you can say is that this sequence A0, A1, A2, ... AK does not belong to G. And you can show that the limit point of this is 0. Maybe I'm wrong.
Yes, you're right. Keep going. You're right.
Yeah.
Don't question yourself.
Don't question yourself.
Because here's the thing. I took one class in like topology, and then I studied the rest of it myself. And that class was like the hardest one I took because I studied physics, like mathematical physics. So I mostly know about like geometry rather than algebra. So. But yeah, so the limit point
let me try to help you reformulate your thoughts.
Okay. Yeah.
So let's say our goal is trying to say that the set G, it has a accumulation point, a limit point at 0, but it cannot contain that. Let me get it. I can draw it and then.
Yeah, maybe if you could let him also write on the.
Yeah, I gave him all the link and stuff. We'll see if
have a tablet.
We gotta get you a tablet. Welcome to the online teaching game. You gotta have a tablet.
I'm working on that. I have a laptop that is not functioning. Yeah.
Oh no, we'll get you there.
So every point interval contains a point that does not belong to C.
What is the interval G, Ramton? What is the inner G? What is it?
G is not an interval.
Oh, it's not?
G can be like I said, open interval can be like multiple open sets can be multiple intervals, but here it doesn't matter because you are only thinking about the situation around 0.
Okay.
So when we say interval has to be one, like something like this. This is an open interval, but an open set could be like a sum of open intervals like this, right?
A
Okay.
union of
Union.
open
Union of
intervals, but that isn't quite relevant here because you are only thinking about the like an open neighborhood around 0.
Oh, okay.
Okay.
Let's see. It contains a
It's,
point.
from what I remember, the definition of an interval is that it has to be continuous, kind of like that, right?
Integrals or intervals?
Interval, not integrals.
Intervals are
continuous.
points and the
So
intervals are
like this is not an interval.
points that happen.
Yeah,
Oh,
it's
I
not an
see.
interval, but it's an open set. It's not an open interval, but it's an open.
So an interval
set.
has to be continuous from a starting to an endpoint. Is that what we're getting at?
Yeah.
Connected, not continuous.
Okay, but it has to have like you can't have like these big jumps in it. I got you.
Not an open interval.
Can you move back to the question? I'm writing down. I'm
Yes,
writing it down.
Yeah, go for it. Go for it. Go for it. You got it.
But open set.
This is point. Let's say xn in 0 and 1 such that xn does not is not in J. So that means for all n there exists xn xn implies xn in C, and then so let us try to prove if 0 is in J and then 1 has this, then
Here's actually, hey, Hypatia, you're writing it out, right, on like a pen and paper?
yeah.
So here's the cool thing. Let me take a picture of like what you do, and then
Okay.
let me come back to it and like go through it, so I can just make sure I can get some of the other kids' questions. 'Cause if they're like, yo, can we do a normal question, please? And like, believe me,
Never.
I love this.
You can do it. Yeah, you can do
Yeah.
that, and then I will finish writing it, and then
Perfect. And then send me the photo and we'll go through it. Yeah, cool.
Wait,
Awesome.
no, my answers. My
No,
point.
we'll get you your points. Don't worry. I like
Oh.
it. You're good, dude. You're good. Here, let me go through real quick, because we got two more questions from other
Teacup
students.
is like, yeah, I'm here for the point.
I know he's like, I'm here for the points, dude. I'm here for the knowledge. Like I appreciate
I'm
learning
here
from
for
you
the
guys as well. Why is this not pasting? All right, cool.
I'm here for the money.
Yeah, nobody said, just when I thought integrals were bad, now we have this, whatever this is. Don't worry, this is like graduate level like math is what this is. Don't worry. You're not gonna have to do this in high school. Okay.
You're gonna have to do this tomorrow in your math class.
Oh, this is another one of these challenge questions, dude. A 2-digit number formed by any two adjacent digits of a 2017. What?
Go just try to ask for a normal office hours.
God damn it. Y'all asking these like super challenge questions. What? 2017 digits is divisible by 17 or 23 if the last digit is 1. Ugh. What? Excuse me. The fuck is this?
That's dope.
Any two adjacent digits of a 2017 digit is divisible by 17. Or actually, no, this is not. I think this is wait. Okay, this is okay. There's two ways doing this. There is I think a more rigorous way of doing it, but sometimes I like to cheat a little bit.
All right, let's cheat. Let's cheat today.
But it's not like, you're not wasting hours like doing this question.
Yeah, I don't want to waste hours.
So there's a number that, there's a bunch of like numbers, I don't know, whatever.
Sure.
Every two adjacent digits of this, if we take them, they're divisible by 17 or 23.
Okay.
So let's actually take all of the different ways that this could be. So 17 34.
Mm-hmm. Oh, I see. Okay.
51. 68.
Mm-hmm.
Another 75.
85.
85.
Then we're
And
done,
then
right?
we no longer can go.
So then we have 23, 46, 69, and then what is it? 92.
92. Is
And
that
then
it?
that's it.
Yeah, 20.
Okay.
Yeah, there we go. 92. So, so if these numbers are right next to each other,
Yes.
there has to be a way that we have to
Oh,
be
and
able
don't they also have to
to-
be this way? Is this also what has to happen?
Yeah, exactly.
Right? Yeah. Okay.
So if there is 17, right? The left of this is the left and right of this need to be such numbers
Mm-hmm.
such that that number would either be divisible by
So it has to be like 51 in this case, right? Because I don't see anything else
either-
here with a 1 in the ones place, right?
exactly. So 51, but the question is, can we have 70 something that is divisible by 1?
Ah, we can't. No, we can't.
We
I don't
can't.
see 70 anything. Okay, so this is bad.
Yeah, this is how we're cheating our way
Okay,
through.
I
it.
like
It's not
this. I like this. Yeah.
yeah, it's kind of like more clever. Maybe there is a more rigorous way of doing it, but like
Yeah. With like some number theory.
yeah, so 17 can't be there.
Yeah. Nope.
All right, now let's go 34. If there's 34, we could have 23 on this side.
And we can have
And we could
46.
have 46 on the other side.
That one works.
So this is, let's say, a candidate.
Mm-hmm. 51
now if
won't
we have-
work. Oh wait, 51 will, because you could have 80. You could have 51. Sorry, you could have 85, right?
Yeah, but then 17 wouldn't work because then it has to be.
Oh, it has to be
17
one
up
from
there.
here and one from here, though. You're right.
No, it could be
Oh, no,
either of them. But if
Oh,
there
okay.
is 51,
Yeah.
then the next number has to be 17 in order for it to work.
Oh, but
once there's
17 is bad.
7, nothing can't go to the other side of it.
Got you. Okay. So
Yeah.
goodbye
So
51.
that's why 51 wouldn't work.
Uh-huh.
Hopefully, I'm doing this correctly. But
No, I think you're
then,
right. 68.
68. We could have 85. We could have 46.
Okay, so we're
Okay,
good.
that's nice. This works. If we have 85, we could have
I don't see anything with 8. Oh, wait, I see 58.
a 58.
Right.
Or 68. Yeah, 68.
Or so 68, sorry.
we,
Yes.
already, we already had. And then it has to be 51.
But 51 is no good.
51 is not good. Think so.
Yeah.
Yes. So then 85 wouldn't work either.
Okay.
Which means that 48 wouldn't work. Wait, this is downhill.
Wait, why 48? We didn't have 48, did we? Did we anywhere?
No. 40.
46, you mean?
46. No. Yeah, wait, where did we have 46?
Right here. 23, 46.
Okay,
Right?
Yeah, so then 46 meets it. 92.
I don't think 92 works because I don't think I have anything else with 9.
80. Yeah, so 92 doesn't work unless it starts with a 9.
Ah, okay. Unless it starts with a 9.
It could start with a 9. Yeah, and it also ends with a 1.
Oh, wait.
So it's
92 be
ending
okay.
with a-
Wait, because what about 69 and 23? Sorry, my bad. 92 is okay.
Oh, yeah. That's at 60 now. Yeah, sorry.
Yeah.
Yeah, so then I think these thing work for we can start with a 9. Yeah, this is fine. This is fine because we could the other side could be 46.
Mm-hmm.
And then 2 could be 23. Yeah. 3, the other side could be 34.
Mm-hmm.
4 could be 46. Yeah. And then
Okay. Oh, here's the interesting thing. The last digit is a 1.
yeah, so I'm pretty sure this is going to create a pattern actually. And then
But wait, but we don't have anything with a 1.
Yeah, the 51 that we crossed out.
Oh, if it's the end.
Because we can't start with a 17, but we can end with a 1. So if we're actually 51 at here, then 85 works as well.
Oh, yeah.
Because then it would be like this. 68 works as well.
Uh-huh.
So that's fine.
This
I
is
think
actually,
here's what
it's a loop. It's a loop. It's a loop. It has to be.
Yeah,
the last digit
exactly.
has to be 51, which means the next one has to be 85.
Yeah, and then I'm gonna work backwards with the loop. So
Yeah.
if this is 51, this is 85, and this is 68.
Mm-hmm.
Then this is 46,
Mm-hmm.
34, 23,
Mm-hmm.
92, 69, 46.
Yeah.
Does anything? Oh, no. And
Yeah.
then 46, something that ends with 4, 34.
Okay. And then 23.
23, yeah, 23. And then 92. Yeah,
Okay,
there
so
we go.
so we're
Then we
looping from here. Right? Or,
Yeah.
or where is it? Where is this
So I
looping
think
from?
the loop starts from a 40 from
Yes.
here.
Good. Okay, yeah, from here on. Okay.
90.
And then how big is the loop? It's
69. So yeah, like 46, 23, 69.
Uh-huh.
Or I guess this is the loop. Yeah, you're right.
So it's 5
Yeah.
big, right? So if we go to 2015, that's got to be 403 loops, right? And then but that's it's too much. Sorry, because we need 3 digits here.
Yeah, so we need 3 digits. And you said 2015.
402. It's 402, right? Gets me the 2010, right? Or yeah, no, because I
402 times 5. Is that what you're doing?
Mm-hmm.
Yeah, and then we go to 2015. Yeah, that's great actually. So this is gonna last 3 digits is the 217, 16, and 15th digit.
Mm-hmm.
So past here we're gonna have 2000
14. So we have 4 more digits. 4 more digits
yeah,
out.
so we go 2010. Our loop has ended. So now we need to go 4 more.
Yep.
So we go 6, 4, 3, 2.
Yeah, so the answer is 2. Cool. Is the answer 2? Nobody? Is it 2?
Please tell us.
Please tell us it's 2. It is! Yes!
Okay.
That's a cool one. GG, yeah. Oh man, dude, that's so cool that it loops like that one. Oh man.
Yeah.
Okay, so I have typed the answer up in the
What's up?
office hour.
Well, let's pull it up. Let's pull it up. One second. I'll get you. Where is it? Oh, nice. You put this in latex too. I like this. Okay. Okay. Oh, so that's the question, and then here's the solution to it. Okay. Do you want to go through explaining this so that it might make some sense?
Yeah, so as I said, like I figured out like a more if they know about topology, like the person would just know like the basis, which like every good kinds of topology can be generated by a basis, and for the Euro or Euclidean topology over the real numbers is generated by, as I said, the basis of form open intervals. Like that's the first sentence. And so the basis, it has this property that for every point in every open set, like the open set that the set open set has to contain a basis element that is that contains the point. So this is the central argument. In this proof, there will of course be a lot of other proofs, but so Oh, so here we are using like a proof by contradiction.
I see.
So we are assuming that 0 is an element of
Okay.
G. So now there is like a basis element, this open interval, let's say like from A to B that contains 0, and that is contained in G. So one may then find a natural number n such that 1 over n prime is less than b, the right set,
Correct.
like the delimiter. And this is, well, I should write that this is possible because there is this the Archimedean property of the real numbers.
Okay.
But like sometimes one just like one mathematicians write that they
Like 1 over
assume
anything is
along-
always going to be like a fraction, basically.
No, it means something like you give me like this real number, it must be bounded by two numbers of the form 1 over n and 1 over m, one on the left side, one on the right side.
Gotcha.
And then this and also the rational numbers are dense, so like basically every two real numbers between them there will be a rational like a rational number. This, like, for example, if it's 0 and b, right now I'm just picking this specific rational number 1 over n prime. So if
Gotcha.
you think about it, you have 0 and you have another real number b, and then there will be a
natural
1
number
over n
and prime
for some n contained inside, right?
Okay. I get that.
Okay. So now you like 0. So this open interval from 0 to n1 over n prime is a subset of G.
Yes.
Which contradicts the hypothesis because the hypothesis tells
It's
you
proving that 0 is not contained in G.
No, we are trying to contradict with the hypothesis.
Okay.
Like we already assumed the contrary to the goal. We have already assumed that.
Oh, okay. I got you.
That's proof by contradiction. So we are trying to establish this contradiction to the hypothesis that for every n there is a point that does not belong to G. But I have already we have already established that there is this whole small open interval inside of G. So for every n that is greater than n prime, there will be no such point that is not in G. So that contradicts the hypothesis to establish this proposition.
Okay. Cool. I like that, dude. Thank you, man, dude. That makes a lot more sense to me.
Can you ask the person asking this question if they have followed this argument?
I don't think they have, because the person asking this question is in 8th grade. So they're very young for math, but they want to learn new things. So I think this is a very cool way of, like, you know, introducing higher level math topics to students who are like bored with what's going on in their classes. And even for me, dude, I didn't understand a lot of this beforehand.
But they asked this question. That means the person is really good, like really advanced in their learning. Like
yeah. Teacup is very advanced and is very smart and is very curious, and I like to foster that and encourage that. And so that's why I tell them to ask harder questions that they have no clue about, because they'll at least learn something rather than having to, you know, repeat doing the Pythagorean theorem over and over again until they're like bored, you know. Cares about that.
Do you want to ask the person, the teacup person, to ask me any question or for clarification?
For sure. Yeah, no, I will. Yeah, I'll let Teacup know. I'll make an announcement actually in the Discord. I'll give you like a position and whatnot, so that if anyone has like any higher level math questions they want to ask, or if they want clarification on this, for instance, they can DM you. Is that cool?
Okay, great.
Cool. Awesome. I appreciate that. Okay, we're a little bit over time, but I'm cool with that. So we had 2 other students with questions, but this is a good opportunity. I want you guys to, because we have a Cooper and Sawyer here. If you can try using the AI that they've developed to ask your math question, I'll give you a bond coin if you go through it. Just try it out. I realized today we spent a little bit more time on more advanced math topics, but it's nice to have a balance of things. So yeah, for Habib and Lemons, can you try asking that question using the AI that we have, and then just show me a screenshot that you got the answer from it. It's on right now. They said they have the bot working right now. I think they'll have it working for another 20 minutes or something. But I'm curious to see if they've added like equation stuff and whatnot to it. So let me know how it works. Otherwise, I will do your question first on Wednesday when we start off. Cool. Ooh, he says I can abuse this. Yes. Yes. Yeah. Noise will definitely find Hypatia very interesting to keep asking math questions about, and I'm here for it.
Yeah, Noise, keep me in the loop. I want to learn more topology as well.
Yeah, right. Let's learn some topological geometry math stuff. I'm here for it.
I think one of the things I also realized in the question that what is considered a topology, so we can talk about like the power sets and all that stuff at some point if we want to talk about topology, because to tell that the geometry, the Euclidean geometry is generated by the set of A and B. We need to understand what is the definition of topology.
I agree.
The topology is not about the power sets, but well, topology is an actual structure you give to a set to some extent, and then you can talk about what is open. And also to go over that, I will it will be a full course. I'm willing to take on that, but if you want to schedule me a time, I can teach topology, I guess.
For sure, yeah. So we have a whole stream on Thursdays that we do. Is more like open ended, just talking about stuff. And I'd like to get to the point where we can offer like full courses. Again, attention span is a big thing here. Is I want to make sure that like if you're spending the time to talk about a subject and whatnot, that you have an audience that's willing and like respectful enough to be there to understand it. So maybe it's something we can start with like maybe some like mini lessons, some like bite-sized stuff to get people like interested in it and whatnot. And even I would love to just improve my math knowledge in knowing these little things. And then once that builds into a community that is ready for that and whatnot, then I think that would be very cool to like start offering like more extensive courses in it. People just want.
Yeah, well, you just give me a 1 or 2 day notice
of course,
when you want me to talk about it, and
I
will prepare for it.
I appreciate that. Okay, cool. Maybe we'll do that for this
Thursday. Where do you teach, by the way, if you don't mind asking?
What?
Where do you teach?
In Long Island, Stony Brook University next semester, right? But they will probably just assign me to teach a recitation, like a problem section for calculus students.
Yeah, so he's kind of like bored. He's like, I know much more math, but they're gonna make me just teach calculus.
Yeah, I'm an algebraic geometer, so I of course want to teach algebra.
Yeah.
Well, if you ever want to teach algebra, I'll definitely want to learn more. So yeah, because that's the area of math that I don't feel that much comfortable. I'm a very visual person, so like I understand calculus, differential geometry, and these stuff. But topology and algebraic topology is just over my head.
Yeah, our school's research, they are mostly using differential geometry. They don't like, so differential geometry and algebraic geometry are quite different. We can study this, like the objects we study, they overlap, but the methodology we use is completely different.
Yeah. Okay.
Awesome. All right, cool. Well, I appreciate that, all you guys. It was really fun. I learned a lot. Next stream is gonna be Wednesday. It's gonna be an hour later. We're gonna start that at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. I have like 40 minutes before I gotta go teach another student. So if you're hanging around and you wanna, calculus seems interesting, yes, we'll go into it. Nobody asked. Don't worry. If you still want to hang around, the next thing we do is I play video games with the kids. That's it's a little work, a little bit of play. So if you want to join in on, I think today's Fortnite. We're gonna do some Fortnite games. That's gonna be on our actual gaming stream. So if you're here in the Twitch, you'll get transported right over. As here, I'm gonna rate it, so that'll make it. But But yeah, also, if you found us and you're interested in all the cool stuff we're going through, there's our Discord. Please join. That's how you can find out about all the activities we do. We stream 3 times a week, sometimes a 4th time when we do the bonus sessions. So I'll let you guys know all about that. Okay, cool. Thanks, guys. If you want to come play Fortnite, meet me in the Recess voice channel. Otherwise, I will see you guys on Wednesday. Thank you again. Big thank you to Hypatia and Ramton for explaining a lot of like cool concepts, high-level math stuff. I appreciate you guys. I really do.
Mm-hmm.
All right. I will see you guys on Wednesday. Peace out.
See you. Have a good day.
You too. All right. There we go. All right. All right. Then let's stream on this. There is. Live. It's a me. God. Is it you, God, dude? What do you want? God, what do you want? God is here.